And so I present to you face detection that works entirely in the browser. For this demonstration, I choose the following technology stack: face-api.js, which uses TensorFlow and already trained models under the hood. It's like you have a personal neural network. ReactJS on a TypeScript to build the front end. MUI for minimal styling. I don't know why I used it, maybe it's just a reflex. TensorFlow is a library that can be used for JavaScript-based machine learning. And yes, it's not just a Python. Interestingly, there are already pre-trained models, so to speak, ready to use. First, let me show you a live demonstration of how it works. Let's launch the project. Let me remind you that all actions take place in the browser. The first possibility is simply face detection, that it is generally present. The second one is landmarks, facial contours. The third is a facial emotion detection. The last one is the determination of gender and age. Gender detection works fine, but there are problems with age detection. For example, if you shave and cut your hair, you can easily lose from 3 to 5 years. And light also matters. To make it all work, separate pre-trained models were used. And yes, this is classic React, with the only difference being that the public folder has a non-typical models folder. This is where you need to place models and weights for them. By the way, if anyone knows if it is possible to train these models and adjust the weights, please leave a comment, because I haven't gotten around it yet. In SRC, the flat structure is a classic React components. Face detection contains all other components and calls call handlers. Message component, this is alerts, determines which message should be displayed under certain conditions. Message about the video stream. Constants. Hooks. I used hooks to make the logic a little easier, so that there is not too much code in one file. And of course models, since we use TypeScript. Since face detection is our main component, let's look at it in detail. Imports. Next, a state that tracks the active control button. Refs. Here we put the video element and the canvas. Next are the hook calls. First, you need to activate the user's webcam. More precisely, the user must activate it. We transfer the video stream from the webcam to the video element, which we will receive in the video ref. Then, when we have a video stream, we need to download the models that we have placed in the public folder. The next hook is face detection, which uses the same methods, which, by the way, I advise you to refactor and clean up at your leisure. Here we already use the downloaded models. We activate the required function and transfer the results to the canvas. On the canvas, on top of the video stream, we draw the necessary mechanics depending on the selected function. Switcher. Depending on the activated button, the button activates the necessary handler with a certain interval. Return section. The message component, which message to show depends on the condition. Controls are control buttons. The video element And the canvas. In the video, as I said, we broadcast a stream from a webcam. On the canvas, we drew the result of artificial intelligence. This is how it works. I don't see any point in going into the details of the hooks, because as always, I'm adding a link to the Git repository with the code. And of course, you can run it all locally. See you soon, sleep tight.